Hi everyone, this video is for section 6.7, solving rational equations. In order to solve a rational equation, we're going to use a little bit of a trick. So recall that whenever you're adding or subtracting fractions, we just really need to find that common denominator. And then really all the work that we did in terms of addition and subtraction happened with the numerator or the top value. So what I'm actually going to do first, or one of the first things that we should do when solving an equation, is we should focus our attention on the denominator. Let's make sure that we have a common denominator amongst all of our terms. So it looks like I have one term has a denominator of x minus 4, another denominator has a value of x plus 5, and then our third denominator has this entire expression of x squared minus x minus 20. So at this point, we should be kind of thinking along the lines of, being crafty and kind of saying, I wonder if I can take x squared plus x minus 20 and factor it down. At this point, what I would recommend doing is pausing the video and trying it out. So for the sake of time on the video, I'm going to actually kind of use the other two denominators here as context clues to see if that might help me out or move me along. And what I'm going to notice is that x squared plus x minus 20 does boil down to x plus 5 times x minus 4. So this means that I need to basically adjust so that all of my denominators match. So remember our example of the kid. Each child that we have here is not happy until they have exactly the same thing as their siblings do. So I'm going to rewrite the problem that I see here with just a little bit more space. So this way I'm not really writing on top of my work, and that I can kind of keep everything neatly organized. And I'm going to use the factored form of this denominator for my third term. Okay, so I'm going to do my adjustments in green. So I notice here that I have an x plus 4 in this denominator, and this child needs an x plus 5. So I'm going to multiply the top and the bottom by an x plus 5. Remember, I have to multiply the top and the bottom in order to maintain the value of that fraction. If I were to just multiply the bottom or just the top, I would be changing the actual value of that number. It's kind of like, for example, if I changed like a 1/2 to like a 5/6, they're not the same number. As opposed to a 1/2 and comparing it to a 2/4, they are the same value. 2/4 just looks bigger, but I can reduce a 2 from both the numerator and the denominator. So coming along here to my second term, I see that I'm going to need to give it an x minus 4 because it already has the x plus 5. And really quickly, we can note now all of the denominators in these three terms have an x minus 4 times an x minus 5. Just a little bit of a side note. Notice here we have a 0 here, and we could say that this is 0 over 1. If you really want to be thorough, you do not need to do this, but if I have a denominator of 1 over here, I need to multiply both the top and the bottom by an x plus 5 times an x minus 4. In this case, since it's 0, it's really not necessary because what is 0 times anything? Hopefully you're saying 0 here. So 0 is kind of a special case. We can kind of ignore that. But we do have a common denominator amongst all the terms now, so what I'm going to do is I'm just going to focus on the numerator, okay? The denominator is not gone, we're just ignoring it. We're going to need to use it as a check, though, when we're done, so don't completely push it off of your paper or pretend that it never existed. So if we rewrite this, my first term is going to be 3 times x plus 5. And then we're going to have plus 2 times x minus 4. And then we're going to have plus 18. And that is equal to 0. So we'll go ahead and we will distribute this through for this first term. And that's going to give us 3x plus 15. And then we're going to distribute this positive 2 into that binomial, and that's going to give us plus 2x minus 8. and we still have our plus 18, and that is equal to 0. At this point, we can kind of start to combine like terms. So I'm noticing I have a 3x and a positive 2x, so they will add up to 5x. And then also note I have a positive 15, a positive 18, and a negative 8. So if we were to add all of those up together, we're going to get plus 25. And that equals 0. So notice now we've actually boiled this down to pretty like introductory algebra work. So that should kind of be making us happy because we can probably knock this out no problem. So I'm going to subtract 25 from both sides, and this is going to give me 5x is equal to a negative 25. And then we will divide both sides by 5. And that's going to give me x is equal to a negative 5. This is the only solution that we have. But what I want to note here is we should check it to make sure that it's not an extraneous solution. In other words, it's an extra solution. It kind of looks like one that we can call it a day and say, yep, that's my answer. But it actually could cause us a problem. So I'm going to write down the original problem right next to it. So we had 3 over x minus 4 plus 2 over x plus 5 plus 18 over x squared plus x minus 20 is equal to 0. What we do always want to check is we want to do a quick plug and chug, at least into the denominator. So if I put a negative 5 in here, I would have negative 5 minus 4. That's going to give me a denominator of negative 9. Cool. We're okay there. We can have a denominator of negative 9. If I were to go to the second one, I would have negative 5 plus 5, which gives me a 0, which that should be rather alarming because we cannot have a denominator of 0. So if you run into the situation where none of the answers that you have found work, how we communicate that to someone is we say no solution. Negative 5 is an extraneous solution. So it's deceptive. It looks like one. It came out of our work, but it actually proves to actually not work when I plug it back into our equation. I hope this was helpful. If you do have any other questions, please let me know.